Okay, this is a quick video illustrating the portable solar time tracker that I'm working on. Um, this is kind of a follow-up of what I have done for a prototype version. I've already done a YouTube on the prototype, but I just wanted to follow up with where I am with this prototype. Um, I've got it pretty much working. I'll show you this is the um, this is the unit. It's all set up. I've got a time lapse. Um, the time lapse starts at around 7 o'clock, and then it starts to move at 8 o'clock. And the way it works is that the actuator that I have controlling the tilt, which is the tilt here is um, from east to west, and the actuator is 10 inches long, and so I have 10 segments, and the 10 segments allow me to every hour move the actuator up by 1 inch. And so it goes up by 1 inch, which ends up being over at around 5 p.m. And then at 5 p.m. it says that uh, the, the tilt is all the way out. It's the actuator is at 10 inches, and now it's going to retract back um, to all the way, which would bring it back to what I started out with is 7 a.m. So the goal here is there is a lot of solar trackers out there. I really haven't found one that I've wanted to use on my RV, so I decided to make my own. And I'm mainly focusing on the controller, not this hardware piece, even though I'm going to use these for my own use. But the controller is the thing that I'm mostly interested in, and also seeing if it makes sense to actually build more of these and see if it's something that some of the solar companies would be interested in buying. So you can see now it's up around it's around 3 o'clock right now, and it's continuing. It's going to go up till 5, and then 5 you should see this retract all the way down, and then it's just going to get ready for the next day. I'll show you a little bit about the frame because it is kind of bulky. So, and plus I wanted to make this so that you could take it apart and put it into your car easily. The solar panel is 5 o'clock, so you see it already retracted all the way back. So now it's ready for the next day. So that's pretty much it for this time lapse. I can get out of this. But here's the panel itself. So what I've done is let me zoom in a little bit here. I've got this set up so that this piece right here, actually I've modified it since this picture, but there's actually a bolt and a wing nut that goes through this pipe onto this what's called a PVC saddle, and it just snaps onto the pipe. And so I put the bolts in there so I could position it in the proper spot. And so you can take the bolt out, unsnap this, take this cotter pin out, and this whole bottom assembly comes apart. The front, I don't have a good shot there, so let me go back to the first picture. So the front here, this pipe comes out, and what this does is there's 3 pipes, and this is the pipe for the winter, because in the winter time it's when we're tilted the most. And so I didn't really want to do any actuators or anything else from the tilt from north to south, because obviously it doesn't happen very often, and it doesn't really gain you much. So what I've got this set up for is this is going to be for the winter solstice, and then when we get into summertime this pipe is much longer, and then the panel is essentially pretty much flat because the sun's going to be coming right up over the sky. So let me show you a little bit about the controller. Okay, well here's the azimuth. So again, I'm not real interested in the altitude, but essentially the controller starts at 7, and then every hour it goes up by 1 inch. And I've got it set up in such a way now where um, after the fifth um, the fifth iteration of this thing going up by 1 inch, it's pretty much flat. It's facing straight up at noontime, and then when it gets down to 10, it's all over for the day, and then it just goes back to 7. That's essentially what the time lapse did, but this is just to show you where the panel is at the particular time. Okay, here's the controller. It's pretty basic. Here's that actuator motor, and here's the battery. The battery is the solar system battery that we're charging with the panel. It's actually not one battery, it's many batteries. And then we have this set of relays here, and they go by this combination. There's a Raspberry Pi Zero that I've got here with a real-time clock. And the reason I have a real-time clock is because the Raspberry controllers don't have a real-time clock, and when if they're not near a Wi-Fi, then it doesn't provide the time correctly. So essentially, and that's when you reboot the thing. When you reboot a Raspberry Pi and there's no Wi-Fi, there's no date and time that's correct. So this module right here was one that the people in Raspberry recommended, and I set this up and it seems to work great. So, but anyways, there's 2 signals right here that control the 2 relays, and so the state of each one of those signals, for example, when they're both set to a 1, the motor is off. When A is 1 and B is 0, the motor goes forward, and then when A is 0, B is 1, then the motor goes in reverse. So that's all it really takes, is these relays right here. The only other thing I added is that we only have 12 volts on this setup, so I had to get a 12 volt to 5 volt converter to provide power to the Raspberry and the real-time clock. So here's the stripped down unit before anything has been assembled. Here is the unit when it's fully assembled. This is the cable that goes to the battery, and this is the cable that goes to the actuator. Okay, so here's a battery that I'm using just for my demo purposes, and here's the controller. There's not really much to it. This is obviously going out to the actuator, and that's the cable right here to the power. Okay, here's the this is actually the controller that I have. The Raspberry Pi Zero W has Wi-Fi, so I've got a little, the application that's running on the Raspberry also supports WebSockets. So I've got this set up so that I can get information about where it is and what it thinks that the real-time clock time really is, and also this azimuth chart right here. So here are the different zones or periods or hours or whatever you want to call them. So the black ones right here and all the way through the nighttime hours, the panel doesn't move at all. But then here at 7 a.m. it starts to move, and every hour it goes up. So right now in this illustration, the panel is at 12 o'clock, probably pointing straight up. And then by the time it gets to the 5 o'clock hour, it's all over, and it just happens to go back to the 7 o'clock time. And that's it. I just wanted to bring that up. Some of the things that, again, what I was interested in is I wanted a way to have a portable solar tracker, so I could just set it up when we stop at some camp area or whatever, and I wanted it to be just a cable I could bring out and set it up. Um, the couple notes that I have here is that time lapse was just to show the panel how it moves, and it really wasn't functioning. It really needed to be facing south, and in that section that was on the back of our deck, it wasn't. It was just facing in an ideal spot so I could get the camera running. And also the controller, it's real. It only has wires that go to an actuator. So if somebody else wanted to make their own tracker hardware, and if they wanted to build a stationary one, this controller should work just fine. So that's about it. Thank you.